All right, so as we saw yesterday when we looked at some of those limits, when we took the limit of f of x as x approaches c, it was just f of c. We just replaced the x with c, we actually came up with that limit. Sometimes we have functions that are well behaved where we can actually just use direct substitution. So again, direct substitution with my function, some of my functions I can just replace x with c. So in this case, we have the limit of f of x as x approaches c. What would that equal? Absolutely. Again, direct substitution, just replacing all my x's with c. This happens quite a bit for our functions, in particular for some functions like, or some of our limits. Here we have b and c real numbers and a positive integer. A lot of this I can use my direct substitution. If I have the limit of b as x goes to c, x approaches c, where do you think this is? What's the limit of 5 as x approaches 2? I'm sorry? Absolutely. What's the limit of 5 as x approaches 7? 5. What's the limit of 5 as x approaches negative 5 million? This 5 has nothing to do with x at all, does it? There's no x's in there at all. 5 is just a constant. So here, if I had the limit of b as x approaches c and b is just a constant, what do I end up with? And that is just my constant function. Here we have the limit of x as x approaches c. What are we going to wind up with here? Absolutely. Just direct substitution. Here we're going to wind up. Limit of x is going to equal c. And this is just my identity function. What about the limit of x to the nth power, where x is approaching c? C to the n. Limit of a power function. And finally, the limit of the nth root of x as x approaches c. That one here. Absolutely. We're just replacing our x with our c. Nth root of c. N is even, c is positive. This is just my radical function. So direct substitution, all I'm doing is replacing my x's with my c. Sometimes it is just that simple. There's nothing else to do. We also have some properties of our limits. So if we let b and c be real numbers, n is a positive integer, f and g are functions, such that the limit of f of x as x approaches c is L, and the limit of g of x as x approaches c is k. First one we have a scalar multiple. So I'm multiplying my limit by b. So the limit of b times f of x as x approaches c. Absolutely, b times L. Think of that scalar multiple, we just pull it on out to the front. And then I'm just left with the limit of f of x as x approaches c, which we already know is L. What about the next one? Here I'm doing the sum or difference. The limit of f of x plus g of x as x approaches c. Absolutely. It's the exact same thing as the limit of f of x plus the limit of g of x. So it's just L plus or minus k. What about the product? So there we can split that up as the limit of f of x as x approaches c times the limit of g of x as x approaches c. And my quotient? Absolutely. Our L divided by K, as long as K is not equal to 0. And finally, our power. Melted in power. Again, if we have that function, we don't have to worry about any dividing, square roots, anything like that. All it is sometimes just doing my direct substitution, replacing my x with my c, come up with that answer. So here, we want to find this limit, the limit of x squared as x approaches 4. How do we get that? Absolutely. Coming up with 4 squared equaling 16. The limit of 5x as x approaches 4. My direct substitution, right? We just wind up with 5, replacing my x with that 4. 5 times 4 is 40. Let's see how many of you remember your unit circle. As far as here, we have the limit tangent of x over x as x approaches pi. Answer what? Absolutely. The limit of tangent of x over x as x approaches pi is equal to 0. Limit of the square root of x as x approaches 9. Yeah, we'll go with the principal. Wait. The limit of x times the cosine of x as x approaches pi. Negative. We need a direct substitution, right? We've got our pi times the cosine of pi, or pi times, coming up with a negative pi. Yeah, some of you do remember the unit circle. Good. Absolutely. And the limit of x plus 4 quantity squared as x approaches 3. Questions? Sometimes it is just as easy, folks. Here we're given that the limit of f of x as x approaches c is 4, and the limit of g of x as x approaches c is 6. So here we want to do our scalar multiple, the limit of a negative 3 times f of x as x approaches c. What do we do here? Absolutely. That negative 3, just like that one property we have, so negative 3 times the limit, negative 3 times 4, negative 12. What about the difference? What's that? Absolutely. The difference, I can just say the limit of my f of x minus the limit of my g of x. So 4 minus 6, giving me that negative 2. And then we have ourselves a radical function. The limit of 2 times f of x squared divided by 4 times g of x. What do we do here? Which gave us what? Isn't that a lot easier, folks? Did I have to do any multiplying here at all? There's nothing wrong with saying, hey, I'm going to do my 2 times 4 squared, give me 32 divided by 24, and then reduce it. This way I've taken away half the work, right? Especially if I'm going to have large numbers. If you already have the factors, why don't you just go ahead and cancel out what cancels out? You don't have to do it this way by no means. Here we have the limit of the square root of f of x times g of x as x approaches c. Trying stuff, isn't it, using this direct substitution? I know. So I have to take it slow, nice and slow. Questions on this? So, all this plays hand in hand with our polynomial and our rational functions. So if p is a polynomial function, and c is a real number, just by using our direct substitution, we're going to come up with the limit of p of x as x approaches c is absolutely. It's a polynomial function, right? I'm not dividing by anything or doing anything strange. It's just I'm going to use my direct substitution. If r is a rational function, what is a rational function? That's radical. I actually just used this about 2 minutes ago. I did say that word.
Unit C. Is being divided. When it's being divided.
Yeah, a rational function means when I have a polynomial over a polynomial, right? I have a quotient of 2 equations or 2 expressions. So here my rational function, which is given by r of x equals p of x over q of x. See again a real number where q of c is not equal to 0. I don't want to be dividing by 0. In that case, the limit of r of x as x approaches c is just going to be absolutely. I would just use direct substitution. Again, I know I'm not dividing by 0, so I'm just going to replace my x with my c, giving me r of c, or in this case my p of c over q of c. All right? So here, if you want to find the limit of this polynomial function as x approaches 2, what do we do? Substitute, coming up with 42. No? Nobody should be erasing, especially when you hear me right down 42.
Is that like your number? You said 42 yesterday. Yeah.
You said 42.
If you worked that
I say 42 all the time. It's just now you guys started paying attention.
It's the answer of everything, isn't it?
Exactly. You know it? Somebody knows 42. So, what do we do then? Substitute it in. Let's go with 18. We'll say 42 for all. Or all the answers are nothing but 42. And you say, no, that can't be right. So, here I have myself what type of function? Rational function. What do? How do I know I can do that? That's the first thing I have to do.
Make sure that the denominator doesn't.
Absolutely. Don't just automatically assume I can do my substitution. We have to make sure, as Michael said, that we're not dividing by 0, and it's clear to see. Unless x is approaching -4, we're good to go. Giving us what?
3.
Questions? Don't worry, I have more stuff than what's on there. So questions on this though? Actually, I have blank pages.